All right. Thank you, everyone, for joining, especially Ms. Hina and Ms. Rabia. Today is the conclusive part of multi-group analysis. In my previous discussion, I have discussed the mean comparison with unequal variance and equal variance. And today, this is the conclusive part for multi-group analysis of mean comparison when your data is not normal. So, first of all, I need to explain the theoretical background of multi-group analysis when the data is not normal. So, the Kruskal and Wallis H test is used to compare more than two groups on the basis of their median when the assumption of normality violated. So always remember when there are more than two groups and assumption of normality is violated, you are going to use Kruskal and Wallis H test as a mean comparison rather than the previous tests which are used which we used with mean comparison of normal data. So what is Kruskal Wallis H test? The Kruskal-Wallis H test is a non-parametric test used to determine whether there are statistically significant differences among the median of the three or more independent groups. So always remember when there is a median comparison, it means you are dealing with not normal data. And if we are going to compare the means of more than two groups, it means we are dealing with the normal data. So here the median is used as a comparison of the averages for more than two groups. So it is an extension of the man-Whitney U test for the two independent groups to situation with more than two groups. So Kruskal-Wallis test is appropriate when the assumption for parametric analysis of variance are not met, such as when the data is not normally distributed. What are the assumptions of Kruskal-Wallis test? The first assumption is that observation within each group should be independent of each other. This means that the data point in one group should not be related or influence the data point in another group. The second assumption is random sampling. The data should be collected through random sampling process to ensure that the results are generalizable to the larger population. The third assumption is ordinal or interval data. The Kruskal-Wallis test is designed for ordinal or interval data. While it is often used with ordinal data, it is less sensitive to the type of data compared to parametric tests. The next one is homogeneity of variance. The Kruskal-Wallis test is less sensitive to unequal variances compared to parametric tests like ANOVA. However, extremely unequal variance may affect the accuracy of the test. So, what we need to do? There is an example number 6. If I would like to show you the data that I have shared with my previous files that I have shared with you. You need to open the previously shared file and you will find here example number 6 and example number 7. While the previous 5 examples we have used with normal data. So example number 6 and example number 7 we need to use. We need to extract this file, for example, on the desktop. And we need to open these files on in our SPSS software. So go to open, go to data, and go to the location where your data is located. So I need to have example number 6 data. So it is open now. So you can see here, it is a data related to some paths scattered and time. I will see what kind of data it is. We need to see the detail in this example. A health scientist wishes to compare the survival experience after breast cancer effort. Oh. A health scientist wishes to compare the survival experience after breast cancer with different pathological tumor size. So it is basically the size of the tumor data and the survival experience data. So you are required to determine whether or not the median survival time of the patient is significantly differ in different pathological tumor size. So this data is related to tumor size and their expected time for survival. If you see in the variable view, you would see there are four different sizes of tumor. 0 indicates 0 centimeter tumor size. Uh, 1 is equal to less than 2 centimeter tumor size. 2 indicates 2 to 5 centimeter tumor size, and 3 indicates the greater than 5 centimeter tumor size. So this is basically the categories of your tumor sizes in case of breast cancer. So there are four categories of tumor sizes, while the other data is related with the time period of survival. That if a person has a tumor size, a particular tumor size, so how many years would he or she would she survive as a patient? So you are required to determine whether or not the median survival time of the patient is significantly different in different pathological tumor size. So what we need to do, we need to use Bruscal and Wallis test. So we go to the analyze, we go to compare means, and we go to non-parametric test because the data is not normal. How we find out the data is not normal? The first thing that you need to do is to go to analyze, go to non-parametric test, go to one sample KS like this. You need to put the time as it is continuous variable and click on OK button. And you would find that asymptotic sig value is less than 5%. If it is greater than 5%, it means data is normal. As it is less than 5%, it means data is not normal. After confirming the data is not normal, you go to analyze, go to non-parametric test because this is non-parametric procedure, and you go to K independent sample. If it is normal data, then you go to compare means and you go to one-way ANOVA. But in case if you are comparing more than two groups and the data is not normal, then you go to K independent sample. So this is where you need to go. So click on it. You need to put your continuous variable into test variable list, and you need to put your group variable into grouping variable list. Now I need to define the range. Before defining the range, I need to see what kind of range I had available. If I see the data of my grouping variable, it starts from 0 and ended on 3. The minimum group value is 0. The maximum group value is 3. It means the range of the data is 0 and 3. So what I need to do, I go to here, I define the range, minimum 0 and maximum 3. So I put it here, click continue. Now I need to verify whether Crystal Wallis H test is checked here. If it is already checked, you just need to click on OK. And you will find here the value, Kruskal and Wallace, and its sig value is less than 5%. It means there is a significant difference between different tumor sizes here. There is a significant difference between 2 centimeter, less than 2 centimeter tumor size, and 2 to 5 centimeter tumor size, and 2 to 5 centimeter tumor size to greater than 5 centimeter tumor sizes. So how to interpret this data? If you see the rank table, there are 826 patients who have a tumor size, a breast cancer tumor size less than 2 centimeter, and their mean rank is 576.17. In the same way, those who have the tumor of 2 centimeter to 5 centimeter are basically 283 patients, while their mean rank is 522.13. And those having the greater tumor size of 5 centimeter or greater, they are 12 in number, and their mean rank is 433.46. So if you see that the uh, mean expected value of their age is declining, uh, in case of less than 2 centimeter tumor size, the mean rank is 576. So they have more life expectancy. It means if the tumor size is less than 2 centimeters, the patients have more life expectancy as compared to those patients having greater than 5 centimeter tumor size, because their life expectancy is low as compared to others. So decreasing value indicates decreasing the life expectancy, because if you see the data is related with the tumor size and life expectancy time. It means if a person has a tumor size of very small, his or her life will be more as compared to those who have larger tumor size. So you just need to interpret like this. So what we have concluded here, we have concluded that there is a significant difference because the sig value is less than 5%. So there is a significant difference between the tumor sizes of between the tumors of different sizes, and those having the tumor less than 2 centimeter have higher life expectancy as compares to those who have larger tumor size. All right. So this is how you can interpret your results. The next one is basically the example number 7. A researcher wishes to compare the weight gain of different groups. You are required to determine whether or not the median weight is significantly differ in different groups. So let's suppose we can take another data, import example number 7 data from here. Now, if you can see here, there are two columns. The first column is related with groups, and the second column is related with weight gains. So what we are requiring here, our researcher wishes to compare the weight gain of different groups. You are required to determine whether or not the median weight is significantly differ in different groups. So we need to compare the weight gains, whether the weight is higher in one group, significantly different in one group as compared to other. So you need to apply the same procedure. So what we need to do, we go to the analyze, we go to the non-parametric test, one sample KS. We need to put the continuous variable in test variable list, click OK, and you will see asymptotic sig value less than 5%. It means our data is not normal. So in the same way, you go to analyze, you go to non-parametric test, you go to k-independent samples. You need to put your continuous variable in test variable list. You need to put your grouping variable into group variable list. You need to find out the values of your group. If you see here, the minimum value is 1, the maximum value is 3. So you need to put here the minimum value 1 and maximum 3, and continue and ensure that crystal values H test is checked here. Click OK, and you will find here that the difference is not significant. So what we conclude here, there is no significance difference between these groups. No creatine, morning creatine, and evening creatine. These are the groups. So there is no significance difference between these three groups because the value is greater than 5%. Those who have no creatine are 5 in numbers, and their mean rank is 6.40. Those having morning creatine are 6 in numbers, and their mean creatine value is 6.83. And those having evening creatine are 4 in number, and their value is 11.75. So the asymptotic sig value suggests that there is no significance difference between the weight gain of these groups. So this is the conclusion of today's discussion. So what we have completed the more than two groups mean comparison today. Tomorrow, we will discuss the correlation and regression. That is basically the that is basically we are moving towards the advanced part. After completing correlation, regression, and regression assumption or diagnosis, we will move to the advanced part, that is regression cases, explanatory factor analysis, discriminant analysis, cluster analysis, process by race, and so on. So this is the end of the discussion. If you have any question, you may ask. Yes, Ms. Rabi and Ms. Hina, do you have any question regarding today's discussion?
No, sir.
All right, so let's join tomorrow. We will discuss the correlation and regression analysis tomorrow. Thank you very much for joining, both of you.